Okay, just a little bit more information on each of these. I think from what we did in class, you can probably answer A pretty easily. Let's talk about B, so illustrating the error for each molecule for each theory. So this is actually a place where a pivot table might be a nice way to show how to do this. So I'll just introduce this idea here. I'm going to open up my data table here. Here's my bond lengths. I've got all of the data that we did before here now. What a pivot table does is it will let us look at this data in a lot of different ways. So I'm going to undo all my check marks and just select all. Not filtering it, I've got all my data points available here. And now I'm going to generate a pivot table. So what this does is lets us summarize this data and sort of orient it in different ways so that we might be able to better plot it in different ways. It's actually a really powerful tool. So let's show how that works. If I go to insert while I'm selected on here, I'm going to insert pivot table. So that's what I want. Insert pivot table. I'm going to use, I called this data table data, so that's what I'm doing. I'm going to put it in the new worksheet just like it says. So I can click OK. So this is a pivot table now. It's being called pivot table 3. And to build a report, I have to choose my fields here. So the way this works is that whereas what we had here is there's all these different ways we could have arranged the data. We could have put the different theories in different columns and things like that. We could have done all sorts of different ways that we could have analyzed this data. And what this does is gives us a really easy way to do that. So let's first just see how we can do this analysis where we had to sort of click in to do all this filtering manually. Let's see how we can do this analysis using a pivot table. So this analysis, remember what we did is we wanted to measure the average of the percent error and the average of the absolute percent error for each of these 3 different combinations. So let's see how we do that here. To generate this table, we want things like this to be the rows. So this is the things that are going to be the rows here is equal to the, what is it we're calling this? The theory and the basis. Those are going to be the rows. The columns are going to be the percent error and the absolute percent error, or actually the values are going to be those. And that's going to be, we're going to do the average of each of those. So let's see how that works. Okay, the rows, I want each row to be a theory and a basis. So that's what I've got, and I need to move those into the row section. So now there's going to be B through LP, HF accurate, HF routine. Those are going to be the 3 different types of theories I have. All right. You can already notice I have a little weird issue here. I've got 2 different things that look like HF. If I click in here, one of these is an HF with an extra space. So that's sort of a problem. If I go back to my other sheet and click Control F and search for HF space, it looks like this right here. We had a test just accidentally added an extra space to this HF here. So if I delete that, and now I search for HF space again, is there anywhere else? No, doesn't exist anywhere. So that was just one little error in our data that we couldn't see because of just that space there. So now if I go back here and I right click and refresh, now we just have the 3 different types of things, B through LP routine, HF accurate, and HF routine. Those are our rows. Then our values are going to be those 2 things that we did here. So percent error and absolute percent error are going to go in our values section. So percent error, drag into values, absolute percent error, drag into values. And I don't want the sum. I'm going to change this to the average. So average of percent error. And instead of the sum of absolute percent error, it's going to be the average of absolute percent error. Again, all this data, these are percentages, so for me I have to click percent and show that as percentages, maybe with 1 decimal place or something like that. Okay, this just reproduced that whole analysis we did, sort of manually back here. So you can already see this is pretty powerful. 1.1, negative 1.4, and negative 1.8%. Let's see that actually matches. 1.1, negative 1.8, and negative 1.4%. So a good match there. That matches quite well, and we have the average percent errors here as well. So that's one pivot table we can make here. We'll call this average error versus model, we'll call it, because that's what we're plotting here, the percent error and the absolute percent error for each of these different models. Not a bad start, but let's make another one now. So let's do, again, this same tool is incredibly powerful. If you play around with this, you can get a ton out of it. So let's insert a new pivot table. And again, by just changing which things we put in the rows and the columns, we can make very different. Okay, so we can just change the fields here to see something else. So in this case, maybe let's break this down by molecule. We'll put that in the row spot. Then what we'll look at is the percent error. That will be our value. And so this is the sum. It won't really matter because we're going to break this down by column, so there's only one value here, but we'll change that just to the average, I guess. This is the average error by each of the molecules, which is useful. It tells us which molecules have the biggest and the smallest error. F2 has a really sizable error when we average all three models together, and so on. Now we can also do is we can put the theory and the basis in the column. So if we do theory, that will let us break things down by B3, YLP, and HF. And I can even put the basis in the columns here as well. So now I have B3, YLP, HF, accurate, and routine, all three of those different settings nicely broken out. I have this HF total, which I don't really need, but these three are quite useful. And this might be a nice chart to make because this now has these three data series, and I can do something like insert a 2D column chart. And this now has all three of those pieces of information really in a pretty decent sort of layout. We can see the errors, right? We've got B3LYLP in blue, and then we have HF accurate and HF routine as the other two. We can sort of see all of those errors together. B3YLP really for the most part making these slight overestimates, and then HF accurate and routine really almost entirely except for BR2 and CL2 making these underestimates. This is a nice chart for going on further and sort of examining which molecules this does best and worst at.